All right. Assalamu alaikum and good evening, everyone. Thank you for joining the webinar. We're sorry for the delay. There's been a minor technical glitch here at our end, but thank you for joining and waiting. I will be your host for today's webinar. My name is Asiya Sheikh, and I'm the director of the Knowledge Hub at the PMI KSA chapter. And allow me to introduce the speaker for today, Doug Oldfield. It gives me great pleasure to introduce him, who will be talking about integrating cost and schedule risk analysis. He is a director of the Fairfield Group, an organization that specializes in providing services to clients in the fields of quantitative risk analysis, risk management, and decision-making. He has been working in this field since 2008, primarily in the Middle East region. And over the years, he also obtained diverse experience towards different industries, ranging from energy, finance, construction, aerospace, and just the list goes on. He has given over 1,500 presentations worldwide. He is an advocate of risk management, and he has been a speaker over several conferences globally. And he has also provided training sessions and consultancy engagements to different organizations. With this, I will give the stage to Doug.
Thank you,
Doug. It's all yours. Oh, just one last thing I forgot. Sorry. If you guys have any questions, please type them on the chat, and we will happily answer your questions towards the end of the presentation. All right, Doug, over to you.
Thank you very much. Can you, first of all, can you hear me okay?
Yes.
Excellent stuff. Good. So the next thing I'm going to do is share out my screen. So hopefully any minute now. Can you see a PowerPoint introduction slide? Can you see that okay?
Not yet, but you have you should be able to share your screen, please.
Yes, there we go. There, boom. Okay, can you see that okay now?
Yes, we can see your PowerPoint now. Thank
you very much. So I'm so used to using Teams that when I use Zoom from time to time, I forget which buttons to press in which order, so you'll have to excuse me. So good evening, everybody. Thank you all very much for joining us today. It's a real pleasure to be here. So thank you very much for arranging this at PMI KSA, and for having me as, I guess, one of your first speakers of the new year. So also happy New Year to everybody on that score. So what we're going to be looking at over the next couple of hours is really a whole number of different things. I think the end point which we're going to be looking at is getting to this idea of an integrated cost and schedule risk analysis and some of the things that we can do with that. But there's an awful lot of steps along the way that we're going to take to get there, so we don't kind of lose people along the way, hopefully. So fortunately, Asiya has kind of covered most of this stuff already. So as she said, I've been working in the field of risk analysis for a long time. I've done lots of kind of training and consulting and so on. And for the last 15 years, I've been coming out to the Gulf very regularly, hundreds of times, I suspect, over that time period. And in fact, I was in Riyadh a few weeks ago. I'm in Riyadh again in a couple more weeks as well. So I'm kind of always over there. I know the industry, know the region and companies and organisations very well. So I'm a director of the Fairfield Group. So we are an organisation that provide services that are really kind of mainly focused in the field of risk analysis, quantitative risk analysis, because that's where we've got so much experience. And what we're really going to be looking at today, if I kind of just run through the agenda quickly. Obviously, the idea of this session is to really give an overview, I guess, of some of the best practices and what the kind of current thinking is really nowadays in the space around integrated cost and schedule risk analysis. But to get to that point, we're going to have a little look about how things were done in the past, and some of the kind of the issues around that, and some of the challenges that were involved. Then we'll kind of have a very quick kind of theoretical overview about what this idea of this hybrid approach for doing integrated cost and schedule risk analysis looks like in theory. And then we're going to do a very kind of practical, kind of almost like a hands-on run through of how it actually works within a tool. So we'll look at schedule risk analysis, cost risk analysis, how we join those things together. And then some of the things that we get out of that. So in terms of the distributions, understand the sensitivity analysis, how we can optimize our schedules, our risk management processes, take into account both cost and schedule together. Excuse me. I've got a slightly tickly throat, and then things like these scatter plots, JCLs, and the isometric curve, which all sound very, very technical, but are really some of the big takeouts that we get from being able to do an integrated cost and schedule risk analysis. And hopefully by the end of the session, you'll understand a whole lot more about what all of these concepts mean, even if they look a bit kind of confusing and high level at this precise moment. And we're going to round off with a Q&A session as well. So there'll be lots of things that are covered over the course of the session. But I'm sure there will be various questions about things that you don't understand or concepts which you want me to explain, which I'm very, very happy to stick around and do after the session finishes. So I guess the kind of the starting point is kind of understanding a little bit about how things were typically done in the past. So I started my journey in risk at working for a company called Palisade, who make the at-risk software. And so typically my first experience in terms of project risk analysis was that I would be talking to cost engineers, typically cost estimators, excuse me, about how to build up a quantitative risk analysis model, which would typically be done in Excel and would be generally focused on costs or maybe the risks and the cost risks associated with those. Then, of course, you would have another silo of people who would typically be looking to use to do the schedule risk analysis. And for that, they would either use PertMaster, if you're of a certain vintage, if you're a bit older, or maybe Oracle PRA or Primavera risk analysis, which is probably the tool that you might have heard of. And generally speaking, those two disciplines were kept very, very, very separate in their separate silos. When I was working for Palisade, people would typically ask, does that risk work with P6? And then when the answer was no, that was the point at which they lost interest. So historically, these two things were typically done differently or separately. So you'd have the at-risk or some type of XI in doing cost, and then you'd have PertMaster or PRA doing the schedule risk analysis. And of course, although it's then possible to come up with things like a P10, P50, P90 for each of those individually, there wasn't really any kind of links between them. And so if, for example, you wanted to reflect these on the schedule, the way that was typically done was to run the analysis in PRA or PertMaster, come up with a P80 value for a particular project or phase, and then apply a daily burn rate to that and put that into the at-risk model as a kind of some kind of link towards the schedule. So obviously that process, that's a manual process, and it's very, very hard to come up with any holistic view on things where all of the risks are shared between cost and schedule and so on. And so the next kind of phase really was to then think about resource load in a schedule, or cost load in a schedule. So where you have a schedule, you have a rate card, and so depending on how long particular activities take, we're able to then calculate exactly how much that's going to cost. But there was a few kind of issues along the way with that. So for those of you who kind of understand what the acronyms mean, so WBS is the work breakdown structure, which is typically what you would see in a schedule. The CBS is the cost breakdown structure, which you would typically see in a cost model. And then the RBS is the risk breakdown structure, which is often, you get to via a risk register. And so historically, because you had these different disciplines who wanted to stick with their own way of doing things, it was very, very hard to somehow massage everything to get them all into the same type of model. So resource loaded schedules, although some people do it, I suspect that, I don't know how many people on the call, 70 or 80 people on the call, I suspect there's a few people who might have done it, but it's something which is not very easy to do well or comprehensively. And there's some challenges around some of the capabilities associated with that. But of course, the issue is that, if you kind of look at the industry as a whole, there are obviously challenges involved with delivering large capital projects within a cost budget or within their schedule. And so typically what you might see is lots of projects overrunning on time or overshooting the cost budget, or indeed overshooting both. And this kind of gives a little bit of an example of some of the statistics around with it. And obviously things like the Olympics and the World Cup typically we don't ever see any kind of schedule overrun, but there is always some kind of a cost overrun associated with it in order to chase that completion date, to make sure that the World Cup, when the first ball is ready to be kicked off, that everything is ready to go. So the industry historically has faced a number of challenges, and my belief is that part of these challenges have come from the way in which we've thought about building up our models, understanding what these risks look like, and the fact that often in the past we haven't really had a holistic view on cost and schedule together, and how they interact, and some of the benefits from doing those two things together. So what the AACEI, which is, for me, it's one of the the foremost authorities in terms of cost estimation, cost engineering worldwide. What they've done, they've put together some new guidance around what they see the best practices being in terms of doing an integrated cost and schedule risk analysis, where what they're looking to do is to bring together the best bits of all the different techniques that existed in the past, and to come up with a methodology that works well, and which organizations can really benefit from. So there's this kind of recommended practice, which this presentation is going to be based on. There's a little bit of a workflow here, which is maybe a little bit dry and theoretical, but I'm going to bring this all to life in a little while. But always very, very, very happy to kind of talk about these sorts of things offline. But I just kind of wanted to give a little bit of an indication as to where all this is coming from. And actually, if you look through this recommended practice, a lot of the screenshots from the tool which they use to show things is also going to be the same tool that I'm going to be showing today, which is a tool called Saffron Risk, which I'll talk about more in a moment. So in theory, how does this all actually look? And these screenshots are from Saffron Risk, which, as I said, I'll explain a bit more about in a moment. But how this works is that we kind of start off with a risk register, and we have we look to assign all of the different, or come up with all of the risks in a risk workshop. Some of those are going to be linked to our schedule. So there would be schedule impacts. So they might be around the amount of time that a task is going to take in terms of hours or days, or the percentage of overrun. Some of them are going to be cost risks, where if this happens, we're going to have to pay a certain amount to clean up the risk, or to clean up the mess, or in terms of mitigation. And then, of course, there's also some links between the schedule and the cost. So if the event takes longer, if the activity takes longer, that is in turn going to drive our cost model, and so it's going to cost more. So we have this joined up approach to modeling, rather than having cost and schedule separate and not talking to each other. And then, of course, the process of Monte Carlo simulation, which I'm going to be talking about in a little bit more detail in a moment, but hopefully something which most people on the call have heard of at least, is that what we're doing, we use Monte Carlo simulation, or quantitative risk analysis, probabilistic analysis, stochastic analysis. All these terms are very interchangeable. But the idea is that what we're looking to do when we run a project risk analysis is to generate lots and lots and lots of scenarios, or versions of our schedule, versions of our cost, in order to really understand what our outcomes look like. So we end up with things like, let me just move that up there. There we go. You probably can't see it on your screen, but I've got a little zoom window that I can see that no one else can. So we end up with things like the distribution curve, showing us what our finish dates looks like, or what distribution looks like. We come up with things like our sensitivity analysis, our tornadoes, and our scatter plots. And so this is where we're going to be getting to in a little while. But before we kind of get to that point, there's a number of different building blocks that I really need to kind of talk to you about and explain along the way. So in terms of what we're going to be looking at then, so the model that I'm going to be using in a moment is a pretty small illustrative model. And the reason it's always best to use a very small model is because it's much quicker to explain things if you don't have thousands and thousands and thousands of activities or tasks. Now, that's not to say that you can't use it on these big ones, because actually you can use this with hundreds of thousands of activities if you particularly wanted to. But for now, this is a very small illustrative model. But having said that, although it's a simple model, there's actually a lot of things that we're going to be talking about over the next couple of hours, or hour and 40 minutes now. And so it's important to note that really the purpose of this session is to kind of give you an overview about what are the best practices in the space, some things to think about, but no one is expecting organizations to go from doing none of this to doing all of it. So generally there's this kind of stage process where this kind of gets implemented. So please don't feel as though it's an all or nothing. There's generally a continuum along the way. In terms of the this next point, as I said, I Fairfield, we come out to the Middle East quite regularly. So if you'd like to find out anything more, to talk in more detail about any of what we're going to be talking about, please get in touch. Tap me up on LinkedIn. I'll flash up my contact details at the end of this. I'm always very happy to talk to anybody who wants to listen about probabilistic analysis, as you'll probably see over the next rest of the session. For this particular demonstration, just to be kind of clear, what we're going to be using is we're going to be using the Saffron risk tool in order to show all these concepts. Now, Saffron risk is really, for those of you who haven't come across it before, but know PERT master or PRA, Saffron is really the next generation version of Primavera risk analysis. So the same team who built the original PERT master tool, Glenn Jarrett and Rusty Johnson, were the people who put together Saffron originally. And so if you've used those tools, then really Saffron is the kind of the new version of that. And what they've done with Saffron is put a whole lot of things in place that people have been complaining about for years and years and years. And so Saffron is this kind of this version of PRA on steroids. But of course, as kind of really along the lines of the first point, just because you can do all these things, you don't have to do all of them. So you could, for example, just do the schedule risk analysis or the cost risk analysis. You could find another tool to do this, or given sufficient time and effort, you could probably do this manually, although it's not something I particularly want to recommend or do myself, I have to say. And really, the purpose of this presentation is to hopefully give some ideas and to start some kind of a dialogue around what are some of the benefits from doing this integrated cost and schedule risk analysis? What are the things that we might want to think about as an organization? How can we improve things? How can we better our outcomes? How can we really think, start to move towards this project risk maturity and these kind of best practices and principles? How can we get there? So really try and be as enthusiastic as possible today. Obviously, you'll see that I'm a very enthusiastic person. I'm typically always smiling. But for me, generally, quantitative risk analysis is one of those things where you get out what you put in. So if you do it because you have to, because the client says you have to, and all you want to do is put in a triangular distribution and give them a PAT, you're not going to get as much as you can out of the tool. So hopefully today you'll be able to see today as a bit of a learning session and see how much good stuff you can do with this idea of quantitative risk analysis. And then finally is the quote that I use all the time from Mike Tyson. Everybody's got a plan until they get punched in the face. And so although we might have a kind of a rough agenda, it might be that things happen, things always happen. So it might be that I do things in a slightly different order or forget a few bits and pieces or talk about some extra things. But hopefully by the end of today, you will have a good idea as to how we can do integrated cost and schedule risk analysis. Okay, thank you, Sile. It's very premature. You don't get a free pass to leave the session just as yet. That should have been right at the end, but yes, thank you for listening anyway. And let's now take a look at how it all works in practice. Okay, so hopefully, could you just confirm that you can still see the screen? Sometimes when you move from one application to another, you lose it on Zoom, I think. So can you now see a screen that says "Welcome to Saffron Risk"? Asia, could you confirm?
Yes, we can see it.
Excellent stuff. Good. Thank you very much. So, as I said, there's other tools are available. The reason I kind of use this one is because we do lots and lots of work with Saffron, and a couple of years ago we had a look around and we decided this was absolutely the best tool for doing this type of analysis on the market. But this isn't a sales pitch to get you to buy Saffron. Obviously, it's a nice thing to kind of end up with, but really I'm going to talk about the techniques here. So although I'm using the tool as the platform to facilitate that, please don't feel that the only way you could ever do this is by buying Saffron, good a tool though it is. So just to kind of set some building blocks in place then. So how Saffron works is that it's a similar kind of methodology to PRA, which is that what we do in Saffron, we would import a project file from P6 or Microsoft Project, but more commonly in the Middle East, P6. So we'd import a project file in order to then start to put some uncertainties and some risks around it. Because of course, excuse me, although Primavera P6 is a great tool for doing project management, actually, when we start to think about risk analysis, it's not so good, which is why obviously PRA was such a groundbreaking tool. And so Primavera allows us to manage our projects in a deterministic way. So in Primavera, we have a schedule, much like this schedule that we're seeing over here, and we have a start point and an end point, and we have a network and links between our activities from the start of the project to the end of the project. But really, this is fixed in stone in Primavera. And so once we import into a tool like Saffron, what we're able to do, I can kind of just show this actually on a step-through basis, but the idea of doing a Monte Carlo simulation and probabilistic risk analysis is to acknowledge that although we might have a plan in Primavera, actually, as a result of different uncertainties and risks and opportunities and all sorts of other bits and pieces, actually, we might start to see a project that is no longer static, but is now moving around. And so the kind of the P6 way of doing things, Primavera is what we call deterministic, and Saffron or PRA or another tool is what we call stochastic. And so stochastic is where there's some variability or uncertainty that's at play. And so this is really the kind of the starting point here. So we've got a schedule, and obviously I'm going to talk about how we get that schedule moving around and so on. But I guess the first thing that we want to be thinking about doing when we're doing any kind of project risk analysis is to make sure that first of all, I guess the information that we've imported from P6 looks exactly the same in the tool that we're using. So this is what we call this is a little piece of assurance, really, because how Saffron works from a technical perspective is that there's not a kind of an API which connects directly to P6. There's all manner of reasons why you wouldn't want to do that. So what Saffron's got, it's got something called Saffron Project, which allows us to represent that P6 file in the tool. And so this is the kind of the first point you'd normally do, which would be that when you bring in a new file, a file from P6, what we want to do, we want to make sure that the file that we're seeing in Saffron has got the same sort of durations and start and finish dates as our plan in P6, which is what we're seeing on here. We've got lots of zeros down here, which is basically saying yes, these are the same values that are contained in Saffron as they are within P6. So we've got all these different types of layouts that we have within the tool. And so this one then is obviously where I get to see my Gantt chart and so on. So this is a file that's been imported from P6. And so generally speaking, once we start doing a schedule risk analysis, the first thing to kind of acknowledge is that however good our planner is, however good the scheduler is, or the person who's building up our schedule in P6, or indeed group of people building up the schedule, because Primavera itself is a deterministic tool, there are things that typically happen when those schedules are built up. So often the methodology is something along the lines of, we need to complete the project by this date. Let's work backwards and understand where these tasks need to be completed. Let's kind of come up with this and hopefully understand what the route is for our schedule. But actually, when we import a schedule, when we import a deterministic schedule from P6, actually one of the first things that we want to do is to check to see if there is anything that might get in the way of us doing a meaningful quantitative risk analysis. And so much like PRA and PerkMaster before it, what we have when we first do an import is we get to see if there are any things that are in our P6 plan that could get in the way of us doing a schedule risk analysis. So these are all various rules that we're checking for to make sure there's no potential issues. So, for example, constraints. So the Olympic Games or the World Cup is a good example of this, because actually when we build up a schedule, we're looking to start when the first ball is kicked. We might have something like a finish on or before date that the planner has put in the schedule, because that's the date which the tournament is going to start. Okay. But actually, when we do a schedule risk analysis, those are almost artificial constraints. And actually, we're not really interested in these, right, we have to finish on this date. What we're really looking to find out is, what's the probability we're going to finish on that date? What are the things that get in the way of us finishing on that date? How much contingency do we might need to add? What are the key drivers that we need to control? And so what these constraints do, we want to look at these before we do an analysis, things just to make sure that there's nothing which is going to cause us any problems. And so, for example, some of these things down here, a project start's got no predecessors, the project completion's got no successors, those sorts of things are fine. But actually, if there was lots of things where there's no successor tasks, then actually the purpose of or the process of running a Monte Carlo simulation or risk analysis, it might be that a particular activity could take 10 days or 20 days or 50 days. But if a task takes 10 days or 20 days or 50 days, but doesn't have any successor tasks, then it doesn't make any difference to our output because it's not linked to anything. And so although those things might be a lot of variability, it's not going to impact upon our project completion date. So all these types of things are things that we might want to check for before we do any kind of analysis, because they're things that might get in the way of us being able to do a meaningful schedule risk analysis. So that's what we're checking for over here. So this is the kind of I guess the schedule side of things. Now, along with that, we've then of course we've got our risk register. So the risk register, which I've got in here, is a risk register that I've kind of set up already. Now, it might be that this particular, the risk registers for a lot of organisations are held in some kind of a risk management database. So I was doing a training session for a large infrastructure project earlier today, where they use a tool called Exactium, which is now Risk Connect. Things like Sword, ARM is another one that's quite common. But ultimately, a lot of these tools, these risk management databases, they're repositories of risks, but they're not particularly good at doing any kind of meaningful cost or schedule risk analysis. So, so this sort of risk register here, this might be in Excel, it might be in another tool, or you might be building up in here. But ultimately, this is a list of all the different risks which we've sat down, we've had our risk workshop, and these are all the different risks which we've identified which could somehow impact upon our project. Now, some of those risks are to do with the schedule, so they're going to cause some kind of a delay, or maybe solve a delay if there are opportunities. Some of the risks in here are to do with costs. So if this particular event happens, we need to pay for it. Or indeed, some of them, like the one I've got on the screen at the moment, are impacting upon both cost and schedule together. So this particular one here, if we just take a very quick look at this, so this, this air transport required risk that I've got going on here is what we call a standard risk. And so there's obviously a few different risk types. We'll look at a few, maybe the top 3 of these over the course of this session. But the idea of a standard risk is one where we have 2 different kind of elements which we're really thinking about. The first is the likelihood or the probability. So, is this risk going to happen? Yes or no? How likely is it that this risk is going to occur? And so, in this case, we've got a risk with a probability of 30%. And then we've got an impact over here. And so what that means is that this is what we call a contingent risk. And so if this risk occurs, so in the 30% of the time that the risk occurs, we're going to see some kind of an impact on our schedule or on our costs. But then in the other 70% of the time, there's going to be no impact at all because the risk hasn't occurred. So we've almost got 2 different kind of elements that we're using when we run a simulation, which we'll talk a little bit more about in a moment. And so these are what we call the pre-mitigated risks up here, and then a little bit further down we've got what we call the post-mitigated version of that. And down the bottom here we've got some mappings. So so these are the different kind of cost elements, which are that little circle, or the activities in the schedule, which are obviously the bar from the Gantt chart. I think this is meant to represent which these have been mapped to. So what this is really telling me is that this particular risk here, this air transport required risk, has been, the description is that we need to transport the goods by air, not road, because of X, Y, Z. I'm not sure what the particular reason for this behind this is. But if we look at this top one up here, this is what we call the pre-mitigated position. So what this is saying is that when we're running a simulation, any activities which have been mapped to this particular risk are going to have a schedule impact, or they're going to have some kind of a cost impact. And so there's different ways that we can kind of characterize it. We've got 2 different types here. So a relative impact is one where the original value, the original deterministic value for our costs or for our schedule, are going to be flexed by a certain percentage. And so, for example, this one here, this relative distribution with a PERT distribution, which is a distribution where there's 3 points, like a triangle. We have a minimum value, a most likely value, and a maximum value. So what this is saying is that we've got a minimum value of 80%, which is this left point on the graph, a most likely of 100, which is this kind of high point, and then a maximum value of 150%, which is this value here. And so if we take a really simple example of an activity which is going to take 10 days, that particular activity, in the 30% of the time, so when this risk occurs, that activity, that 10 days is going to get multiplied by a value that comes from this distribution here. And so actually, in the best case scenario, 80% of our 10 days, it's only going to take us 8 days to complete that activity. In the worst case scenario here, the impact is going to be 115%. So it's going to be 15 days rather than the original 10. So a relative impact is one where we're taking the original assumption and then we're multiplying it by some kind of a percentage. Now, if I was to change this to absolute, then what's going to happen is that if this risk occurs, and of course I need to change the numbers here, but if this particular risk occurs, each of these activities is going to have a certain amount of time which are added onto them. So that's the kind of the difference between relative and absolute, and the same with the cost down here. So this is what we call an absolute impact, and so the cost impact of this particular risk is, I guess, we're going to need to pay for air transportation, which is going to cost somewhere between $100,000 and $280,000. In addition to also having this kind of extra schedule impact associated with shipping, packaging stuff up, putting it in the container, taking it to the freight terminal, and getting it shipped across, etc., etc. So we've got a cost and a schedule impact, and so we have these different ways which we can do things. And so this is what we call the pre-mitigated position. So this is before we put any controls or risk mitigations in place. This is what the impact that we've assessed in our risk workshop. And then, of course, the next part of the process is generally that we then want to start thinking about well, rather than just saying, alhamdulillah, we can't do anything about this risk at all. Typically we want to be thinking about what are the things that we can do to best manage or control that. And so what we've got here are a few different actions which have been identified. I don't know, advanced booking and proposed mitigations and so on. But the idea of this is that although we might have to pay out some cost to mitigate these risks, or some extra time in order to put some processes in place, what we're really looking to do is to try and to improve our outcomes in some way. And so what this is telling me is that actually, as a result of these, we kind of reduce our probability of the risk, and actually if the risk occurs, we think that the impact is going to be less as well. So I think part of that risk analysis piece is really being able to look at the difference between maybe our pre and post mitigation in order to evidence the value or the worth of any kind of risk analysis. Or risk management rather. So this is, so at the moment what we've got here, these are what we call the standard risks. And actually, one of the things I think said on the objective was to talk about the difference between a standard risk and what we call estimation uncertainty. And so a standard risk is one which is something which is, we don't know if it's going to happen. We might have some historical data, we might be able to do some research, we might be able to get input from groups in industry or consultancy companies or past experience of previous projects, but we don't know if they're going to happen or not. Now, the other type of risk which we're going to be looking at is this thing which we call estimating uncertainty. Now, estimating uncertainty is something where you can see that the probability here is actually grayed out. It's grayed out because it's 100%. And so here, there's not a question as to whether or not we're gonna have estimating uncertainty. Estimating uncertainty is something which is inherent in the process of building up an estimate. Because we don't know what's going to happen in the future, we don't know exactly how much something's going to cost, or we don't know how long something is going to take. There is often some uncertainty that goes into the estimating process. Now, that's not the same as a risk, so it's very important to understand the difference between those two things. So the estimating uncertainty is something which is always there, and is the uncertainty that is inherent in the estimating process, whereas a risk event is an event which may or may not happen, and if it does happen, it's going to have an impact on our ability to complete the project within the budget or within the time frame. And so this one here, for example, this is what we call high uncertainty, which is the same as having a very low level of confidence. So the higher the level of the uncertainty, the less confidence we have. And so what this is saying is that actually, for this estimating uncertainty, we think it could be anywhere between 80 and 150%, but we don't really know exactly how long it's going to take. So this particular task here that has been mapped across to this design additional guidance systems from our schedule, we don't know exactly how long it's going to take, but we think that there's going to be some variability around it. And actually, one thing I forgot to do was just to talk a little bit more detail, just very quickly, just to kind of give you a bit of a run through as to what this actual model is. So this is a very simple little example. It's a drone project. So UAV stands for Unmanned Aerial Reconnaissance Vehicle, or drone is an easy way to do it. So we have these different phases. So we've got the preliminaries phase, design, fabrication, construction, testing, and then some reconstruction activities down here. And so what we've done, this particular estimated uncertainty has just been mapped to one of those activities. And whereas actually, as we kind of go through the project phases, or as more information comes in, what tends to happen is that that uncertainty gets reduced, and we have more confidence in our estimates. So if we're sitting right at the kind of the initial project phases, and we are looking to try and understand exactly how long something is going to take, but we've never done this type of project before, then there's a lot more uncertainty than a project. We've drilled hundreds of wells in this particular location. There's a lot less uncertainty around that. So what we have, as we kind of go through the project phases, we have less and less uncertainty, more and more confidence, and so then our envelope kind of narrows, that band of uncertainty narrows down. And so estimating uncertainty is something which is very useful for organizations to employ in a couple of different ways. So first of all, as I said, it's where we don't really know exactly how long something is going to take or is going to cost, but we want to kind of represent some idea of uncertainty. The second is where we don't necessarily not trust is maybe, but we're not confident that the person who's building the estimate has come up with the right numbers. So we know that this estimator is always, he doesn't like his projects to overshoot on budget, so everything costs more in his models because he doesn't want to be wrong. Or we've worked with this subcontractor before, and we know that their foundations or their piling work or cement or whatever, their concrete takes a little bit longer than they say it's going to take. And so what we're going to do is we're going to add a factor to that, and we're going to say, actually, whatever they say in their estimates, what we're going to do is we're going to increase it by between 5 and 10%, and we want to apply this factor to their estimate. So the idea of estimating uncertainty is something which it's always there, and it's the uncertainty which is inherent in the estimating process rather than a risk. So it's quite an important kind of differential to understand. Okay, so we've got our risk register. So we've got our kind of pre-mitigated position up here. We can also, of course, put in a post-mitigated position as well, which I kind of talked about, where we're looking to improve our outcomes as a result of our risk management. And I'll show you how that kind of plays out when we do a simulation in a little while. But I guess once we've got our risk register, the next part of the process is really to start mapping risks to our activities or to our costs within our model. Now, when we talk about costs, historically, some of you may be familiar with this idea of a resource loaded schedule, which is where everything is driven by the schedule. And so how that would work, we would go and, for each of the different activities in our schedule, what we would do, we would build up some kind of a resource rate card, where we start to put in new rate, different rates and resources, etc., for the completion of a particular activity, and then the schedule would drive things. But actually, the kind of the way that things are going now, the general movement is that actually it's better to have this thing called a separate CBS, a cost breakdown structure, that's separate from the schedule. And so what we have here, so obviously on this tab, we've got our schedule with our WBS. And on this tab here, we've got our cost model, which is our CBS. And we've got some links to the schedule, which I'll talk about in a little while. But it's a different approach. And it's one that organizations typically prefer, because what it means is that instead of the cost team having to try and massage their costs into a WBS format, You can have the planners working in the schedule. You can have the cost team working in whatever cost system you use, whether it's Excel or Cobra or Costos or Cleopatra or whatever else it is, where instead it tends to be more of a kind of like a spreadsheet type based approach to doing cost modeling, but in a different way. And so if we look at a schedule, a schedule is broken down by phases, whereas a cost model, we've got material costs, other costs, labor costs, and so on. And so this is the cost model over here. And so really what we're looking to do, we're looking to take our project risk register and we're looking to map it to either our schedule or to our cost items or to both. And so this risk mapping is that kind of process. How does that kind of work? And so what we have here, this is, you can see if I just bring that down a little bit, you can see that on this left-hand side, this is my WBS here. So this is my, the different phases, the overall project, the prelim phase, the design phase, and so on. So these are all the different activities that are in my schedule. And then on the right-hand side, these are all the different risks and opportunities from my risk register. And so if I want to add an additional risk or opportunity, I tick the button, and then all of a sudden that risk has then been applied to an activity within my WBS or work breakdown structure, which is what's just kind of come live down the bottom of the screen there. So these are our different risk events or opportunities. Then the next part along, these are those estimating uncertainties. So I've called them low, medium, and high. And so here, if there are some uncertainties around the amount of time that an activity is going to take, this is where I can then start to apply it to the activities in my schedule. And then the final part here is something which not all organizations do. But some planners will build up a 3-point estimate in P6 in Primavera, and if they have done that, we can also import that as well. So this is what some people call duration uncertainty. So you don't have to have this duration uncertainty. It might be that you've got a single point estimate from P6, in which case this kind of schedule uncertainty isn't even going to be there. All we're going to have is our estimating uncertainty and our risks and opportunities. But if we do have some schedule uncertainty from P6, this is where we can manage and see it on this tab here. So if I just go and pick an item here, let's pick one with a few different risks associated with it. So this is I've got this thing down the bottom of the screen. I don't know if it's blocking out. I'm not sure if you can actually see that or not. I'm trying to minimize this. Can I lose that there? There we go. I don't know. I think maybe I'll put it up at the top for now. But basically at the bottom of the screen, what we've then got, so for this particular activity that I selected, this fabricate fuel system, we can see that there's this duration uncertainty. So it's going to be between 18 and 28 days, according to the scheduler. We've got a little bit of estimating uncertainty, and then we've got a parts supply risk that we're assigning to it. We've got a merger and acquisition risk. We've got an opportunity, some kind of outsource opportunity. So we've got a few different risks which have been applied to it, which is what we're seeing down the bottom of the screen. So these are the risks which have been applied to this activity, this fabricate fuel system. And so what we can see here is we can see what the likelihood is that those risks are going to occur. And we've also got either the kind of the pre-mitigated cost or schedule impacts, or the post-mitigated cost and schedule impact over here. And so if we look at the schedule impact, what we can see is that actually, if we look at this item, what have we got? This item according to our planner in P6 was going to take 20 days. So that was how long has been assigned for this particular activity in P6. But actually, once we've applied all these different risks and opportunities, etc., what we're then able to see is that actually, although the deterministic value, the original value was 20 days, actually in some cases we can end up spending a lot less than that, I guess, as a result of various uncertainties or opportunities. But then out here on the right hand side, this tail means that it could take, if all of these risks kind of all fire at the same time or at the same level of impact, it could take us up to 56 days. So this is what we call a real-time analyzer, which allows us to see what the combined impact of all these different risks which we're applying are to our model. So I'm just going to kind of just explain this in a bit more detail, because it's something which is quite important to understand. I'm also going to have a little gulp of tea as well to lubricate my voice. Excellent. I finally, after 15 years, believe it or not, I drink quite a lot of tea, and after 15 years, I finally got around to having an actual thermos flask which keeps my tea hot, rather than ending up with a cold tea that I'm slurping on throughout a presentation like this. But you can see here, this is showing us these are the different risks or opportunities which have been applied to this particular activity. So first of all, we've got this duration uncertainty, which is this thing we see here. So a minimum of 18 and most likely of 20, a maximum of 28 days of this triangular distribution. That's what we're seeing over here. So we've got some uncertainty around the amount of time it's going to take. We've got this subcontractor liquidation, so there's a 5% chance that we're going to see an uptick of between 100 and 300% in terms of the amount of time that this task is going to take in the event that one or more of our subcontractors goes bust. We've got a parts supply risk, which is only a 15% likelihood, but it's going to potentially add up to 142%, and so on. So we've got all these different risks and opportunities which we are applying to this particular item, and the result of that is that it could take us quite a lot longer than we think, which of course makes sense, but it's quite nice to have that almost instant feedback approach. So if I was to add another risk on here, then virtually straight away we get to see what the impact of that is, which is a very useful part of the jigsaw, because actually when we're running risk workshops, when we're talking to engineers or the planning team or the project manager, it might be that actually this is unrealistic. It's never going to take us 63 days, because actually what we'll do, we'll just go and, we'll get one shipped in, we'll spend a bit more money, but we'll get it done in 10 days or in 30 days rather than in 63 days. So this is a very useful part of that feedback loop when we want to challenge the inputs to our model, because really the whole purpose of running quantitative risk analysis is to make a model that is realistic representation of what might happen in the future, so that we can make better decisions in the present day. And so although you can kind of do QRA in a very much a paint by numbers, we put in a triangular distribution for everything, we have a min, most likely a maximum. Often there's a lot more that kind of goes into it. As I kind of said at the beginning, you very much get out what you put into doing this type of analysis. And so it's very important to be able to challenge things, to challenge assumptions, and to whether you're an analyst building the model and you want to understand why your outcomes are as they are, or whether you're a decision maker and the management, a director, or whoever it is, challenging the people who have built these models' assumptions. It's a very useful thing to be able to do that kind of that auditing or validation and assurance. So this is really this kind of risk mapping screen is where we are applying the different risks or opportunities and uncertainties from our schedule to from our risk register to our schedule. So the next part of the jigsaw then is then let's look at some of the cost side of things. So this cost model here, this is, as I said, oops, whereabouts are we? Lost my screen. There we go. Okay, good. So as I said, I don't know if any of you can see what's going on here, but I've got this black bar which has got all my zoom controls along the top of the screen, and of course because the Saffron tabs are along the top of the screen, I'm just having to move things out of the way so I don't lose them from time to time. But this is what we call this is the kind of cost model that we're looking at. So this is the cost model that might otherwise be done in Excel, but we're doing it all in one place here, because it's just much easier to do it all in one tool rather than having different models that you're trying to stitch together. And so this is our cost breakdown structure. So this is all of the costs for the project. Now, it might be that you don't want to do this. It might be that all you want to do is look at the cost impact of risks. Now, actually in here, I've got material costs, I've got labor costs, but this could just be a standalone kind of risk register. But we're kind of doing it all in one place because I think it's a good practice to do, and a good way to look at things. So what we have down here, this is our kind of the top level of our cost breakdown structure, or CBS. It's the overall project, and then it's broken down to material, other, labor, and then we've got these what if scenarios here. So we've got this total project cost of just under 15 million. And so if I kind of open this up, I've got some material costs, other costs, labor costs, and so on. And so this first part over here is all pretty standard stuff. So obviously we've got the different activities, or sorry, the different cost items. We have a base value for them. So how much is it going to cost us? Sometimes there might be some uncertainty around that. So for example, the parts for fuel system, although we think it's going to be 6 million, actually it might be as low as 4 million, or might be as much as 6.6 million, but most likely around 6 million. So we can have some uncertainty around these base amounts. So if we're not quite sure exactly what I don't know, ton, how much it costs for a ton of steel, we can put that type of uncertainty within here. Likewise, for the quantity side of things, most of these quantities are one, but there's this one here, which could be, we might need up to 3 of these. And again, there's a distribution around it. So there's some uncertainty around how many of these we might need. So this is something which the QS type people tend to quite like doing. So this is very much a standard kind of standalone cost model where we've got a 14.968 million. But actually, when we're running a simulation, what we have, we want to be able to have a cost model like our schedule that moves around. And so if I do this step through on here, oops, that's my schedule. Then hopefully you can see in the cost model that actually our costs are also kind of subject to some uncertainty as well. So sometimes they're lower, sometimes they're a bit higher, etc., etc. So this is this idea of our model being uncertain, and the uncertainty in our cost model is being driven by uncertainty in the base, uncertainty in the quantity. And if I go across to the right hand side a little bit, we've got some links to our schedule, which I'll talk about in a moment, and then we've also got some risks as well. So we've got some different things which are impacting upon these costs that are aside from just the kind of the base amount and the quantity. So let's kind of look at those in a little bit more detail. So first of all, let's look at how we deal with schedule, because one of the challenges in the past, by doing things in at-risk and PERT or at-risk and PRA, was that there wasn't really any kind of a link between cost and schedule. And so what we're doing here, we want to be able to reflect the fact that if an activity is going to take us longer, it's going to cost us more, because maybe there's some labor costs, or maybe we're hiring a rig at a day rate. And so although the cost of rig hire might be in our cost model, actually we also want to acknowledge and reflect the fact that if it takes us longer to drill this, or if we have to pay our laborers for longer, that's also going to have an impact on our costs as well. So we want to have that link between cost and schedule. We want that to be reflected when we do an integrated model. And so although some of these items over here are what we call standalone costs, there's some of them you can see that there's some kind of a link to a schedule. And so what I'm going to do, I'm just going to kind of build this out just so you kind of see how this works. So this item here, this engine cost, components and installation, it's obviously one that we kind of put in here just to kind of to illustrate how this works. So this has got a base value of 2 million. So at the moment, this is going to cost 2 million, and there's one of them. So the amount it's going to cost is a fixed 2 million. But actually, although the cost of the components might be relatively known, what we don't know is how long it's going to take to install them. And so there's going to be some kind of a variable or time dependent portion of costs that are going to be driven by our schedule, by the amount of time that these activities take. And so what I'm going to do, I'm going to say that I want there to be a link to my schedule. And so if I click this little button here, that allows me to set up what we call a schedule connection. And so what I'm going to do, I'm going to click on this thing here, which is called the WBS selector, and I am going to assign it to a particular activity. And so here, for example, this assemble engine components. So I'm going to assume that this is something which is going to be driving that cost in some way. And so, although here the fraction or the portion is 100%, maybe I know, let's stick with some nice easy numbers. Maybe I know that the cost of the components are going to cost me $1 million. And so actually what that means is that my cost team have assigned $1 million for the labor, how long it's going to take in order to do this. So basically what we have a situation where, I'll just scroll across to the right hand side just so you can kind of see this a little bit more. Oops. So at the moment, you'll see that all this information over here is left blank. And so what I'm going to do, I'm going to connect the assembly of that. I'm going to say that 50% is going to be driven by the schedule, which essentially means that my 2 million has now been split into 2. So I've got $1 million of fixed costs, which was the price of my components, and now I have $1 million of variable cost, which is going to be driven by the schedule. So how does this work then? Because in my schedule, I've got a duration of 20 days, which is going to give me a kind of calculated day rate of 50,000 days. So 20 days into $1 million comes up with a nice, easy to explain in a presentation, 50,000 per day. But actually, what we also know is that this task here, this assemble engine components, if we go and have a little look at the schedule, what we can see is that let's do that on a step-through basis again, where we assemble engine components. So here it's 33 days. Here it's 24 days, here it's 24, 29, 24, 35, and so on. And so actually, that million that we're paying in variable costs actually shouldn't be a million some of the time. It should be more than that, or it should be less than that, depending on how long that activity takes us. And so if we go and look at that in the cost model, we can see over on this particular iterate where we were, where am I down here? So this particular iteration was 31 days in our schedule. So rather than it being a million in variable costs, actually it's going to cost us an extra 550,000, and that 550,000 is the additional 11 days above our original deterministic estimate, multiplied by this day rate of 50,000. And so now we've got this variable portion that's moving around. So the fixed rate is staying the same. That's time independent, but this variable or time dependent cost is obviously moving around depending on exactly how long it takes us to get that engine installed. So we now have this kind of link between the schedule and the cost in a way which we didn't have before. But crucially, what it also means is that we are able to have risk events like this part supply risk here, which is independent of our schedule. So some risks are going to drive our schedule, some are going to be purely cost, some are going to be both. But in the old kind of resource loaded model, we couldn't have cost risks that were distinct from our schedule. So everything was driven by the schedule. So it's much harder to do this type of modeling, or nearly impossible. So this is our kind of cost model here. So we've got a cost model where we've got obviously the kind of the fairly standard stuff. We've got links to our schedule here, so to give us that ability to look at variable and fixed rates in a more granular way. And then over on this side as well, we've also got the start finish dates. Now, this is something which we're going to be looking at in a little while. So this is one of the kind of the big takeouts from being able to do an integrated analysis, is that we can then do what we call probabilistic cash flow, which is where we can look at what our funding requirements look like on either a periodic or cumulative basis throughout the time horizon of our projects. So what we're doing here, we're linking the cost of an item with a point in the schedule. And so that point in the schedule could be, for example, we're only going to pay our subcontractor when they've finished this activity, or it might be that we pay at the end of each month. So that's when we're going to budget for it. So we're able to set up in here exactly when we want these cost items. When is that going to impact our cash flow? So whether it's a a materials or labor cost, or whether it's the cost of a risk, what we're able to do here is to say at what part of our project do we think we're going to be exposed to this, and I'm going to explain why that's quite useful in a little bit more detail shortly. So this is our kind of cost model, and exactly the same as with the risk mapping in the schedule. What we're able to see is then what the risks are that we've chosen to impact upon that, and also what that looks like with this real-time analyzer. So this particular one, it started at 2 million, but it could be much higher as a result of this schedule connection and this part supply risk here. So we get to see then this dynamic link between the costs, the uncertainties, and then what that combined impact looks like with this real-time analyzer over here. So we're starting to kind of get these building blocks together now. So hopefully you can see that we kind of start with a schedule, and as part of our analysis, we build up a risk register. We apply uncertainties or risks to items in our schedule, or we can apply those same risks to items in our cost model. We've looked at a couple of different risk types. So we looked at the difference between the standard risk, which is where it's a contingent risk. So if the risk doesn't occur, it's not going to get counted. We looked at the estimated uncertainties as well. And one other kind of little thing to think about as well is this idea of what we call risk calendars, probabilistic calendars. So typically when a planner builds up a schedule, there'll be different activity calendars that get used. There may be various non-working days for, I don't know, Eid or Christmas if you're sitting where I'm sitting in the UK at the moment, or there may be during Ramadan, there might be kind of reduced working hours, so the number of hours in the day is reduced accordingly. But actually, when we think about the risks to our project, sometimes risks can be driven by a particular time of year. They're kind of like they're calendar risks, typically things around weather, for example, which are more or less likely at a given time of year. So here, for example, there's if you looked out my window at the moment, if it wasn't a blurred background, you'd see a very wet scene. It's tipping down the rain here today, or very, very high wind speed. And actually, if you're doing any kind of drone testing and you're testing a flying vehicle in the air, actually you don't want to have high wind speed, because then probably like flying a kite, your drone's going to get smashed to the ground if the wind is too high to cope with. And so what we have, we've set up what we call a probabilistic risk calendar to show what's the likelihood that we're going to get some kind of downtime on any given day because the wind speed is going to be too high. So this may come from some kind of historic data from the meteorological office, or some historic data that we might have, or indeed we might kind of create this from scratch. There's very, very different ways to do this. In the Gulf, it might be, this is the events which may or may not happen. So they're not the predictable things like Ramadan, where we know the working hours are going to be shorter, or holidays for Eid. There may be bad weather events. So it could be sandstorms or really excessive heat, which means that we just can't do outside work on those days. And so although here we've got it to do with wind speeds, you might have a different set of probabilistic risks. And the idea of a probabilistic calendar is it's distinct from that activity calendars in Primavera, because when we're talking about probabilistics, what we're saying is that sometimes the risk might happen, sometimes it doesn't happen. And so rather than trying to do that in P6, which you can't do because P6 is a deterministic tool, what we're doing, we've set it up to say that in this particular instance, for, as I said, this is probably somewhere in the northern hemisphere, we've got this high chance of wind in the winter months here. And so on any given day, we've got a chance that we're going to have downtime. But just because we've got a chance that we've got downtime, also there's a probability that we're not going to have downtime. So we have these two different states. Either we have a high wind speed, or we don't have a high wind speed. And so although this is showing us the average chance, actually, when we start to run a simulation, what we're then doing, we're then able to see, we can then build up these probabilistic calendars, which then reflect those two states. That does it happen, yes or no, in a much more realistic way. And so what this is showing me, or showing you hopefully, is that this is, although when we look at the kind of the average, we can see that there's an average probability. Actually, when we're doing it so there's just one state when you look at the average, whereas when we're running a probabilistic analysis, we have two different scenarios. So scenario one is that the risk doesn't happen, in which case there's no downtime. Scenario two, there is downtime, which is those blue ones there. So we've got these two different states. And so of course, for anything in our calendar, anything in our schedule, whereabouts are we? I think I've got some down here. These calendar ones down here. What this is basically saying is that, if we want to do this testing of the guidance or GPS systems, what we've done, we've mapped those to those particular items in our probabilistic calendar. So these activities here, they will not take place, or they will be affected. There'll be downtime that will affect our ability to complete these two activities here if, when we're running a simulation, our wind speed is too high. And so we've got this link between what might happen in the outside world, in the physical world, and how we want that to play out in our model. So again, it's just a way of kind of capturing that link between realism in the outside world and how we model it. So probabilistic calendar is a very, very good way of doing that. So I just kind of wanted to flag that up, because it's something that often people don't really think about when they're thinking about project risk analysis, but it's something which is a very, very powerful technique and very important on big projects where you might have significant chunks of downtime as a result of weather, which you want to incorporate into your model in order to understand in order to understand it better. So we've pretty much got to the end of the inputs. We've got the ability here to also correlate things. So correlations is a topic we'll maybe save for another day, or if people are interested, we can always set up another session on this. But correlations are really, the idea of correlations is that what they allow us to do is to draw a link between two or more variables within our model. So if we have a delay at this part of the project, that's more likely to mean a delay here. if one subcontractor goes bust that's supplying us with these parts, it means that it's more likely than another subcontractor is. Or if this costs more, it's probably going to, it's probably going to take longer, etc., etc. These are what we call correlations, which are basically it's a way of drawing those relationships from the outside world in our model, and that's something which is very, very important when we're doing any kind of probabilistic modeling. But I'm gonna park it to one side because I don't want to get too bogged down in the weeds for now. So now we've got to the point where we've set up all the different inputs to our model. One thing I didn't mention actually was this idea of a lessons learned library over here, kind of like a repository of what we call global or historic risks. But that's something which we're not really going to be looking at today anyway. But suffice to say, this is a kind of like a database, if you like, of risks that we want to think about on new project risks or that we're working on. So this analyze then is where these are the kind of some of the things that we think about when we're talking about QRA, when we're talking about running a simulation. These are some of the things that we need to think about. So, for example, here, the number of iterations, that's how many of those samples, how many different scenarios do we want to think about, do we want to look at? I'm going to run it with 1,000 iterations. We could run it with 10,000 or 100 or 1,000,000. There's some different, there's a lot of pros and cons around different ones. But what I'm going to do, I'm going to run a model with 1,000 iterations. I'm going to ignore pretty much all these other things for now because you kind of don't really need to talk about them on this particular session for the moment. On the left-hand side, I'm going to choose whether I want my risks to be at the pre or post mitigated state, or indeed some kind of a blended approach, which is what I've got here. So of course, in the risk register, and when we look at the risk register, we explored the fact that we can have what we call pre-mitigated risks, or indeed once we've got some actions or controls in place, we might be in a post-mitigated state. And so what I'm doing here is I'm selecting whether or not my controls or mitigations have been implemented or in place yet, or if I'm still on this kind of untreated or raw or kind of pre-mitigated risk profile. So this is what I'm doing on this side, and we'll come back to that in a moment because there's some quite important things to think about with that. But for the moment, I'm gonna run a model where most of my risks are at the pre-mitigated state, except for a couple which are at a post-mitigated. These focused activities over here, we don't need to really talk about them today too much, but essentially they're little shortcuts which enable me to jump to a particular point in the schedule or the cost model very, very quickly and easily. So I'm going to click Run Analysis. And so now what we've done, of course, just to kind of recap, we started off with a schedule from P6. We looked at the schedule warnings in order to see what the suitability was for doing a QSRA. We then applied some estimating uncertainty, some duration uncertainty, and some risks. And then in running that simulation, that 1,000 iterations, what I can now see is what the chances are. This screen sharing thing's really annoying. I've got no idea why I can't hide this. Let me just see if there's a way to lose this. Let's just say I can dock it to the top or I can dock it to the bottom, but I can't hide it altogether. Never mind. I'm sure there must be a way to hide. Oh, excellent. I've now hidden those floating controls. I don't know if you can see that. There's a message saying you've now hidden them, which is good. Okay, so this is now this is the results from our QSRA. So this is our schedule risk analysis, where our original schedule had a completion date of the 14th of July. And we can see that based on all those different risks and uncertainties and so on, that actually, although the planner originally said we were going to complete on the 14th of July, once we had all those different risks and uncertainties to our model, we can see that actually we've only got a 17% chance that we're going to be able to complete our project within the original given time frame. So then what we're also able to see is what then, if we wanted to come up with a particular confidence level, what would that look like? So for example, my P80 is this point here, this point on the S curve. So we have what we call an S curve, which is this kind of cumulative curve. We have a histogram, which is the bars, or we can kind of have both of them together. So my P80 is out of those 1,000 iterations, those 1,000 scenarios, the P80, it means that that's the value which in 800 out of those 1,000, we managed to come in before that point. So in 80% of our cases, we completed our project before the 23rd of the 9th. So if we wanted to talk about our P80 out how much contingency we need to add, we can see that actually, if we wanted to be 80% confident, which is going to be the difference between our P50 and our P80, we would need to add in, excuse me, I can feel a sneeze coming on. We'd need to add in 35 days of contingency to our schedule in order to be 80% confident that we are going to be able to complete within this given time frame. So this is what we call a contingency curtain, and I've coloured it this kind of red and green to give the idea that if we don't add any contingency, we have a lower chance. There's a risk we're not going to be able to complete. Whereas the more contingency we add, the greener the better the outcome. I think the human mind kind of very hardwired to see red and green as good as bad and good respectively. So this is our kind of our initial QSRA, so we can calculate what our P80 or our P90 is, or we can even find out what's the probability if the 14th of the 7th is only a 17% chance. What are our chances we're going to be able to complete this project before the summer holidays start in earnest on the 31st of July? And actually, we've only got a 32% chance we're going to be able to do that. So we can either look to find out what the chances are we're going to complete by a particular point, or we can use the tool to calculate our confidence levels. So this is looking at the finish date, but we could also look at the duration, for example. Now, this is looking at the schedule side of things, but of course there's another button up here which is showing the cost results. So my schedule, this is my overall project, or I could look at the what the finish date is for a particular phase, or even what the finish date is for an individual activity if I wanted to go down to that level of granularity. So we can inquire at any level of our WBS, what the chances are that this particular phase or this sub project is going to be completed in order to be able to hand over to the next part of the phase. So we can look at that level when we're looking at the schedule. If, on the other hand, what we're interested in is the cost side of things, then of course we're able to do that as well here. So just like my CBS model, I've got material, other labour and what if scenarios. So it's kind of broken down by those, or I can look at the project on the whole. And actually you'll see that that here I've got a slightly better chance that my cost outcomes are going to be met than the schedule. So I've got a 30% chance that I'm going to come in or under my deterministic budget of just under 15 million, but it's still a 70% chance that I'm going to overshoot that. So this is our kind of our cost risk analysis. So we looked at the schedule risk, the QSRA, the schedule risk analysis. This is the QCRA, the quantitative cost risk analysis. And before we get onto the integrated side of things, there's a couple of other little things that we can pull out of this type of analysis. So the first is that we can look to see what are the key drivers. So what are the different risks which are impacting upon the finish date, or what are the different activities, the duration of the activities. What are those things? What are the things which are most crucial in terms of us being able to complete our project by the given date? So what these are called tornado charts, where we're ranking the relationship, or the relative relationship between the inputs and the outputs. So the wider the bar, the more significant those inputs are. And this can be a very useful thing in terms of trying to do that root cause analysis. So what are the things that are getting in the way of us completing our task? We can obviously go and explore all of that type of thing. But really, when we look at this, I can see here that there's a correlation coefficient of 0.238 between my internal communication issues and the finish date of my project, which is utterly meaningless to absolutely everyone else. If you go and talk to senior management or the CFO or the CEO and say, well, look, actually we've got this, the biggest risk is internal communication. There's a 2.38 correlation coefficient. No one knows what that means. I don't know what that means. I don't know if that's twice as bad as a 0.12 or if it's the human brain doesn't really think in terms of correlation coefficients, it's fair to say. And so for those of you who kind of used PRA previously, Primavera risk analysis, one of the big differences with Saffron is that Saffron has got a database in the background. And so having a database in the background means that we can store results from different simulations. So what we'll talk about this in a moment, this distribution comparison. But what it also allows us to do is to open up this idea of what we call a sensitivity analysis by exclusion. So the idea of a sensitivity analysis is really that we're looking to try and understand, if we take all these risks from our risk register, what's the actual time or cost impact of those risks occurring? And so if you wanted to do this in PertMaster or PRA, the way to do it would be that you'd run a simulation, you take out one of the risks from the risk register, you'd rerun the simulation, and then you calculate the difference between those 2 points, which we call the delta. Then you put that back in, and then you take the next risk out from the model, run the simulation again, compare the results, and do that over and over and over again, which could typically take a week or more in order to complete that task. And so what the development team for Saffron did was to basically connect into a database means we can automate that process. And so what I'm going to do, I'm going to use the tool to tell me what's the actual time or cost impact of those risks in terms of my overall model. And so if I calculate impacts, you can see that this is looking at the overall project itself. And I'm doing this at the P90 level. So what this is saying is that at my P90, I'm just going to take that one out because I've got something strange that I put in there. What this is saying is that actually this wind speed risk that we've got in our model, the impact at that P90 level of that wind speed is that it's going to be 18 days. If we look at the P80, which is what I was using before, it's 19 days at the P80. So if we could somehow magic that wind speed away, if that risk away, if we maybe test in a big hangar or whatever it is, then actually that's going to save us 19 days from our project. That internal communication issues, that's something which, if we could deal with that, that's going to save us 10 days on our schedule. So this is the time impact of those different risks on our schedule. Now, of course, we could look at it with the kind of S curves instead, and there's a lot of information on that at the moment. So let's say this is what it looks like with no risks removed, and then my wind speed one, which was that 19 days of difference. So so just to kind of explain in a little bit more detail where those numbers on that tornado have just come from. When we run the simulation, if the wind speed is present in my model, then my P90 value, or rather the P80 value, which we've got here, is that we're going to complete on the whatever it is, the 24th of September. But if that wind speed risk is taken out, actually our P80 value here, we managed to complete whatever it was, 18 or 19 days earlier. So that 18 or 19 days, that 19 days rather, that difference is the difference between this point here where the risk is present in our results and this point here where that risk is taken out of our results. So this tornado, let's do it for everything. So what this tornado allows us to do is to see which of the risks are the most important in terms of our overall project. So this is, of course, just looking at the schedule side of things. Now, for the cost, if I turn it over to cost, you can see that actually how I've set this up is that I'm not just looking at cost on here. In addition to cost, I'm also looking at the finish date as well. I'm also looking at the schedule impact as well. So the light blue bars up at the top are the schedule impact, and the kind of like the darker blue bars are the cost impact. And so what this is then showing me, both of those two elements together. So when we come to do an integrated analysis, what this allows us to do is to really kind of start thinking about how we want to manage to prioritize both objectives, so for example, this one up here, I mean, it doesn't matter what the actual risk is, but this one here is, that's 3 days for our schedule. And so this one here is 3 days, this one's here is 3 days as well. And so if we were doing this independently, then we might assume that actually the thing that we want to really focus on is the wind speed, which is going to add 19 days. But actually we can see that this one here is going to add quite a lot of cost. And so if we were more interested in keeping our costs low, this is the thing that we might want to look at first. If we were interested in schedule, this is the thing that we might want to look at first. Or indeed, if we want to look at both together, then this one's 3 days, this is 3 days, this is 3 days, but the cost impact of this is 1.48 million. The cost impact of this is 137,000, and the cost impact of this is 67,000. So maybe this is the one that we might want to look at focusing on first, because that's going to be the thing that's going to help us to manage not just our schedule, but also our cost as well. So this sensitivity analysis is it feeds into this idea of stochastic optimization. It allows us to try and understand what are the things that we want to try and control or manage from a risk process in order to help us to meet our objectives. Now, obviously, up to this point, we've been, I've talked about schedule, I've talked about cost, but we've been looking at those two things independently. There's a 17% chance we're going to complete our schedule or complete our project within our time. There's a 30% chance we're going to complete our within our budget. But actually, what happens if we bring those two things together? And so this thing here, which we call a scatter plot, is where we do that. And so on this particular scatter plot, you can see on here, there's 1,000 dots on that screen, believe it or not. I think some are overlaid on top of the other. But along the x-axis, we've got the finish date of the project. So this is showing us our schedule. Along the y-axis, this is showing us our cost. So the schedule, it looks like the kind of the best case scenario we're going to complete sometime in May. The worst case scenario, we're going to almost move into 2024. In terms of the cost, we might complete down here is the lowest point, 12 million, but actually in the worst case scenario, it's going to be more like 22 million up here. And so what we're able to see is that actually, if we're looking at schedule where we've got a 17% chance of coming in within a particular of completing by a particular point, we can see that 17%, some of the time we manage to also come in under our cost budget as well. So underneath this little area here is where these green ones are where we actually manage to meet both cost and schedule objectives together. So that means that we finish under budget and we finish within our costs. And of course, we've only, within our schedule. And so we can see that actually we've only got an 8% chance of meeting both of those objectives together. Sometimes if we spend a little bit more money, we can still complete within our schedule. On this side of things, if we can keep our costs low, but then actually it's typically going to take us a bit longer. Or the red ones are where we miss out on both of those objectives together. So those are ones where we fail on cost and indeed schedule. So this is a really kind of useful part of the jigsaw, because of course, when you're looking at cost and schedule separately, you might be able to say there's a 30% chance of coming in under our cost, or a 17% chance of coming in within our schedule. But what this allows us to do is to quantify the chances of both of those. And what it also means is that I think it's very, very easy to, if you're doing things separately, for the cost team to say, oh, well, actually, do you know what? What we'll do, we'll just take a little bit longer on it, but we'll be able to keep our costs down. Or the schedulers will say, well, it's okay, if we get stuck, we'll throw a little bit more money at it. But what this allows us to do by seeing the two things together, it gives us a much more kind of holistic view on how our project is going to perform. So this is what we call a scatter plot view. So we've got the time and the cost on the same graph together. So it's basically taking the information from this distribution graph here. So it's taking all of these data points here. So the data for the durations, or for the finish date, or for the costs, and it's plotting them together on this scatter plot. Now, I think that's brilliant in itself. We could look to see, what are the chances that we're going to be able to complete the project within our budget, or we could see what are the chances that we're going to be able to complete a particular phase within a particular amount or sub-project, or how much we're spending on a particular subcontractor. We could go down to that level of granularity. So we can put any values on this scatter plot here. We can compare any cost elements versus any schedule elements. We can do that within here. But one of the things that's been gaining popularity in recent years is something called the joint confidence levels, or JCLs. So I've just kind of changed the view on here, and obviously what you can see, rather than having some red, black, and green, I've now got some different colours which are involved on this. And so the JCLs, if I kind of hover over one of these particular, in fact, let's hover over this point here, somewhere over here. Let's find a value somewhere around here. Oh, there we go. Okay, so you can see this is what we call a tooltip, and so I can see that in iteration 298 I had an X value, so that was my schedule, that was my deterministic finish date, the 14th of July, and I've got a budget or a cost amount of 14.785, and so that JCL of 8%, it's telling me that if in my project charter or my project budget, I choose a completion date of the 14th of July, and I have a budget of 14.78 million, then I would only have an 8% chance that I'm going to meet both of those objectives. Now, NASA, that's people who build the space shuttle and other bits and pieces, of course, in the US, what they found was that, obviously, the costs got blown, the schedule got blown, but actually it's not sufficient just to take the two things separately. You need to have some way of being able to quantify those two elements together. And so this JCLs were born out of NASA. And actually I've got this little document here. You can do it if you do a search on for NASA JCLs. There's kind of a little bit of an overview on here. It kind of talks to you about it. It's a little PDF. I'm not a hacker who's hacked into the NASA mainframe. Don't worry. This is something which is available on the internet, but it kind of talks a little bit more about why they've done this. And so what NASA do when they do their projects, and actually it's not just NASA, it's starting to feed its way into different industries in the US and also worldwide as well, because now I think the DOE or the DOD in the US are starting to do this as well, which is now what NASA are asking for is a JCL of 80%. And so they are asking to have a confidence level of 80%. And so that's what the project's budget and schedule are sanctioned at, with a JCL of 81% or 80%. So it's not enough for the cost team to come up with a PAT and the planning team to come up with a PAT. Actually, they have to build an integrated model where they are able to evidence that the joint confidence level, i.e. the probability of meeting cost and schedule objectives, is 80% or higher. Now, this actually kind of starts to throw up some quite kind of interesting things when we're talking about kind of risk management and how we can do this, because if we start to have the ability to get to a particular point, it then starts to open up conversations about how do we want to get there. So just like the sensitivity analysis screen, which we just saw, allows us to see the cost and time impact of the risks together. By having this JCL view, what we're able to do is we're able to sit there at the start of the project and when we're starting to talk about contingency, how much contingency do we want to allow for risk, either from a cost perspective or from a time perspective, we can now start to slice things up in different ways. So for example, here we have a JCL of 80%, which is focused on cost. And so what that means, you can see that these bars here, there's one line that goes here, another line that goes here, and what that means is that if my target completion date is the 9th of the 7th and my target budget is 235 million, then I have an 80% of completing that. So that's kind of one way to get to a JCL of 80%. Of course, if I was more interested in my schedule, which is where I want to complete the project sooner, but actually that's going to come at a cost. It's going to come at a cost of spending an extra 10 million in this case, but I still have this JCL of 80%. So here I'm more focused on my schedule than on my costs. Or maybe I want to have some kind of a more balanced view where I'm looking at cost and schedule. I'm not really too fussed which way around. And so here we've got somewhere in between those 2 points where we're happy to look at cost and schedule together. So this kind of JCL view here, what it also allows us to do is allows us to think of something called an isometric curve. Now this is quite an interesting point, at least if you're a geek like me, but I think hopefully you'll see the business value of this as well. Because sometimes there is a tendency to throw more money at things in order to complete sooner, or on the other hand, sometimes there's let's keep our costs down, but take a little bit longer to complete the project. And so this little blue line here, this is called an isometric curve. It's a kind of a necklace. And basically at any point on this line, this is where we've got a value of a JCL, a joint confidence level of 80%. Now, from a risk perspective, actually, when we're starting to look at this, so sure, this little bit here, we can kind of, if we take a little bit longer, we're able to keep our costs down, but there is a point where this flatlines. And so even if we're kind of adding extra contingency for our schedule, it's not actually doing anything for our costs. And so, although we might take longer, we're still spending the same amount. Whereas at this point here, we can going up the curve in the other direction here, we can spend more money in order to complete our project sooner. But then there's also a point we get to around here where even if we do spend more money, if we add extra contingency for our cost here, we're still not completing any sooner, because this line's gone vertical, and so we're spending more money, but we've got nothing to show for it. And so what the implication is that this point here, around to this point here, are the bits that we can really play with. These are the bits we want to be talking about from a contingency, from a management perspective. Whereas actually, once we go vertical or once we go horizontal, actually we can't impact on the outcomes in a beneficial way. So we probably don't want to be just throwing good money after bad in order to complete our project sooner, because however much we spend, it's not having an impact. It's the bottom line with that. So we get some quite useful kind of turnouts from these JCLs. It's a really, for big projects. I appreciate that if you're looking at cost and schedule separately, to get to this point might seem quite a big journey. But actually, when we're talking about projects that are billions and billions and billions, which of course so many of your projects are, what part of the reason I love the Gulf and Saudi in particular is just the scale of the projects that you're working on is mind-blowing. It's enormous. And so although there is obviously some work to get to this point, I think it's a really, really, really valuable thing to be doing from a management perspective. This is exactly what I would want to be seeing from my whether it's the subcontractors or the consultants or the people working on the project. I think that this is really what project risk maturity looks like. Now, in addition to being, once we get to this integrated analysis, once we get to the point where we can look at cost and schedule together, whether it's here or doing our kind of like our analysis within the tool, one of the other things that we can do is something called a probabilistic cash flow. Now, what the probabilistic cash flow allows us to do is to look at what our funding requirements might look like through the whole life cycle of a project. So historically, you might have a cost budget, you might have a schedule, but actually by linking together costs and schedule, which was something that I kind of mentioned briefly earlier on when I said that, look, we can choose exactly where we want these different costs or risks, or the cost of risks to be felt. This is the kind of accumulation of that, where we're then able to see. So this particular project, I've got it on this annual view here. You could look at it by quarter or whatever, but then there's more data to talk about on the screen. So I'm just gonna talk about it on this annual view here, and I'm also going to put on a little. Not the data view. Let me also put a little legend on the screen as well, just so you can kind of see it briefly. Hopefully, it's all going to be visible. Yeah. Okay. Good. So, what this is showing us, these bars are what we call a periodic spend at a given level of confidence. And so what we can see here is that the red one is our P20, and this dark blue one here is the P99. So we can see that actually in year one, there's not really an awful lot of difference between our P20 and our P99. Really, there's obviously there is a bit of a gap, but there's not much variability. Whereas actually in year two, we can see that the difference between our P20 or our P50 and our P99 is much bigger. So there's a lot more variability in terms of what our fund, how much money we might need. So and then in year three, that kind of drops down again a little bit. Let's just take that legend off for now, just to kind of clear a little bit of space on the screen. Then this line here is the cumulative amount. So by a particular date, how much do we need to kind of budget, at a given level of confidence? If we're talking about our P99, which is a very, very high level of confidence, this line here is how much we would need to make sure we've got available to fund this project from oil revenues or whatever else it is that's going to be funding these projects. This is where we can, this is how much money we need to have available if we want to be really confident there's going to be enough money in the bank. Alternatively, if we're looking at our P90, which is the yellow one, that's how much money we might need. The P80 is here. So the bars are the periodic spend, and these lines are what we call the cumulative spend. And actually, the eagle-eyed amongst you might notice that these black dots on the screen, these are showing that these are the results from our kind of cost time scatter plot here. They're kind of, obviously the scaling is slightly different, but that's what those black dots are, in case anybody's wondering. And if we go to the data view here, we can see that, kind of that evidence in a bit more detail. So for example, this periodic spend, I said that there's not much difference in our first year between the P20 and the P99. Actually, there's around about $1 million, but that's not a huge amount of money. Whereas actually in year two, the difference between the P20 and the P99 is more like 6 million. So there's a lot more variability. And then in year 3, that drops again. So the bars are showing us how much we need to at a given level of confidence. And then on the right hand side, that's the cumulative spend. So we can see that actually for the whole of the project, by the point at which the project completes, there's about 5 million of difference between our P50 and our P90. So if we were P99, so if we wanted to be extra confident we've got enough, that's how much we budget. We might budget more around here, or maybe we're going to have some kind of contingency or management reserve that we're going to allow the project manager to spend over the course of the project. So this probabilistic cash flow is, we could flip it on its head. We could have this as a contingency drawdown. It's a very contentious issue. How much, how do we start to release contingency back once the risks are passed? We could kind of reverse this and see it in a different way. But this PCF, it's something which we can only do when we're running that kind of integrated analysis where we've got cost and schedule together in the same place. Now, some of the other, just to kind of wrap up on some of the other things that we might want to think about. First of all, this distribution comparison. So I mentioned that PRA and PertMaster were what we call flat files. We have a database on the back end of Saffron. So what that means is that we can run different scenarios. So I've got all manner of different reports here where I'm comparing lots of different things, some of which are very geeky for kind of QRA nerds like myself. Some of them are a little bit more practical. And so this one here is, I've got 3 different simulations. So I've ran 3 simulations for my model. And so in this settings, I mentioned that I could choose pre or post or current. And so what I did, I ran 3 versions of my model. Model number 1 was where I might have had some uncertainties, but I didn't want to put any risks on it. So before I applied any risks or uncertainties, I ran a simulation. And then once I got some results, I sent it to this point here. Then I ran a second model where I had everything at the pre-mitigated state, and the third model where I had everything at the post-mitigated state. And so these 3 curves are showing us those results. And so curve number 1 was the initial model, the uncertainty estimate, where if we look at my P90 without any risks at all was 15 million. Then if I have all my risks at the kind of pre-mitigated state, so before we got any risk management processes in place, actually what that's done is it's going to add, I don't know what, just over 1 million for risks. That's how much contingency I might want to allocate at the P90. Or if we then start to think about the impact around mitigations or controls, so once we get to a post-mitigated or treated perspective, actually I can see that I managed to bring that down from 1 million to 500,000. So that's the value of my risk management process. We can kind of evidence that type of thing here by comparing those different scenarios, which is very, very useful. And finally, I think the thing that I always like to finish up on is this idea here of this critical path map. So when we build a model in P6, everyone is very, very focused on the critical path. So the shortest point, to get from A to B, from the start to the completion, what does that critical path look like? But of course, when we run a simulation, the fact that we have a schedule which moves around as a result of the uncertainty means that actually sometimes you get tasks on the critical path that aren't always there. And so, for example, what this is showing me, this criticality score here, this is showing me what percentage of the time these different tasks fall on the critical path. And so obviously there's a lot of them that are always on the critical path, but we've got a few things down here which are on the critical path less than 100%. And the fact that you've got tasks which sometimes are on the critical path, sometimes aren't on the critical path, the implication of that, of course, is that means that a critical path goes from being this fixed thing to being something which moves around. And actually here what we can see is that we've got a whole number of different critical paths. And so although here, my fairly dominant path is this path number 1, which is there half the time, I've got another critical path which is 16%, 13%, and so on. So we can start to see that actually there's points of divergence where actually when we kind of go through, we can see that if we look at kind of everything, at this, by the time we get to the contract completion, we've only got 1 critical path, whereas actually once we kind of go down, actually we've got a second critical path has appeared somewhere around here. I can't remember where they all are in here. There's maybe, no, not there. Here we've got a couple more critical paths have arisen, and so this is something which is really, really, really useful from a project controls perspective as well, where we're able to start seeing whereabouts we're diverging from our original critical path as a result of that simulation. So this is quite a useful thing to be aware of, that actually when we run a simulation, we no longer have just one critical path. We sometimes have a number of critical paths, which then of course feeds into the idea that if your kind of project controls approach is to really kind of make sure you're managing the critical path, actually when we run a simulation, we've got lots of critical paths that are going on here, so maybe we want to think about those things as well. So it's just a kind of a useful little extra thing to talk about. Now, I'm sure there's a number of other things that I could potentially talk about, but I've been talking for quite a long time now, and so obviously I can see that there's a few different kind of questions and answers. I haven't been looking at the chat at all, I have to confess, because I'm just been sharing my screen. So, Asiya, have you kind of been looking at some of the questions which have been asked, you know, in the kind of chat and Q&A? Are there kind of any questions which have popped up so far which you think I should be answering?
Yeah, we've been receiving really good reviews from the attendees. They've really enjoyed your presentation. They really found it useful, so that's very good to hear.
Thank you. Shukran.
No, but we do have a few questions.
Okay.
The first question I'll take is they're asking, how can we manage human and non-human risks together? That's the first question.
Oh, that's a starter for 10. So human and non-human risks together. So I suppose it depends to an extent on how you can kind of categorize them. I mean, for me at least, the purpose of running an integrated model is to try and make sure, as I said, I think during the presentation, that we have a kind of a very full picture of everything that could befall the schedule. Or the project. And so the kind of the AACI guidance, it kind of looks at some of those risk factors, so that, you know, it might be around the productivity, etc. Those sorts of things might then get fed into our activity model at the start. So it might be that within our original kind of model, we might want to be applying risk factors, which we could do through the use of those estimating uncertainties. So, for example, if for example we're not quite sure about the amount of time that something's going to take, we could use something like one of those estimating uncertainties to kind of flex that kind of, I don't know, productivity risk or labor risk, the amount of time that or the resource that it might take. Whereas of course the kind of like the non-human risks, maybe the impact of an earthquake or a sandstorm or bad weather delays or whatever else it is, of course that's a fairly straightforward thing to do. So I think that really when we're building up a model, it's incumbent on us to make that model as complete a picture as possible, because there's no point if you've got all sorts of kind of human risks which are going to have a really big impact on your project, but all you've got in your risk register are some bad weather delays, etc., which are nothing to do with the kind of the human or systemic risks for a project. Then you haven't got a complete picture. So I would always urge to try and get all of them in one place, because then that leads to kind of a better view on our outcomes, if you like, or more complete picture. Okay, so thank you for that one. That was a tricky one to start off with.
So we have question.
Okay.
Yes, we have our second question. Can we import schedule in Saffron with duration in minutes?
Yeah, no, of course, yeah. I mean, I didn't want to make this into a kind of like a sales presentation for Saffron per se, but yes, you can. So when we do the import, you know, we go to the schedule, we go and we can do an import of the project from P6, and when we do the import, it says, do you want to import in minutes or hours or days, and then you can bring it in. And actually, if you've got multiple activity calendars in P6, which is often the case, it will import all of those activity calendars as well. It's worth also noting that you don't actually have to have P6. You could just run all this in Saffron without Primavera. You could literally use Saffron project, which is the screen that we're seeing at the moment, in order to build up a schedule. You can go and put you can build all of your relationships, you can build all of your links and so on within the tool here. So you don't have to have P6. You could just build a risk adjusted schedule in here, very high level. But actually it's I think it's great, because typically you'd have your schedule in P6, so sucking it into here and then having a view of that same schedule is very, very useful. And actually, you can probably see on the screen, this is something that you didn't see previously because I forgot to scan back to this. But actually, this is my Gantt chart. It's exactly the same schedule, but this is what my Gantt chart looks like after I've run a simulation. And so I've customized this to show my what we call the confidence levels on here as well. So what these bars are showing, whereas if we look at this on a step through basis, we can see that, you know, if we go to this schedule back here, we can see this is the amount of time that each of these activities are going to take on an iteration by iteration basis. When we then run a simulation, what we're then able to calculate are obviously things like our P50s, our P90s for each of those. And then what we can do, we can actually represent what that uncertainty looks like on the graph. Oops, that's all right. Go back into my schedule. And so this is now showing me what the uncertainty is at an activity by activity level. It's showing me what the different risks were which impacted upon those. And that kind of purplish pink thing I've got on there is I guess my contingency curve, which is I think the difference between my deterministic value and my P80 or something like that, or P99. So there's some extra customization there. But so that was a very long answer. I went off on a slight tangent from the one about the minutes. But yes, the short answer was yes, you can import minutes. The longer answer is the one that I just gave. Sorry about that. Next question, please.
All right, thank you. Okay, if a risk element impacts on both time and cost, how could we manage this, or how can we maintain the baseline?
Okay. So if it impacts upon cost and time, so I think it's important when we're setting up these models to
Time and cost.
So time and cost. So when we're setting up the risk register, of course, let's move this bloody thing out of the way again. In fact, how did I get rid of it last time? I went to hide floating meter controls. There we go. So when we set up the risk register, what we're able to do is we can set up schedule impacts, we can set up cost impacts for the risks. Now, there's kind of two schools of thought for doing this. So some organizations prefer to have let me see if I can find an example. They prefer to do these things separately. So they will set up a schedule impact in the risk register, and then they might set up a cost impact of the same thing in the risk register. So we can choose whether we want risks to affect our schedule or to affect our cost. But it's important to make sure that we understand what that relationship looks like, because if we've got a risk which, for example, is impacting upon our schedule, if we've then gone and built a link between our schedule and our cost model, then we need to make sure we're not double counting that by having an additional cost impact as well. And it might be that that's a very valid way of doing things. It might be that we have a risk which is going to impact upon our schedule, and so if the activity takes longer, it's going to cost us more. But actually, it might be that then that's also going to add a fixed amount to our time independent or our fixed costs as well. Or it might be that it's better to have those two things as separate. So although I'm not quite answering the question that was asked, I think it's a very important thing to be aware of, that actually we want to, you know, we've got the ability here to have risks which point to our cost model or to our schedule separately, but we also need to be very aware that having a risk, you know, applying a risk to our schedule, if there's also then a link to our cost, we need to be very careful not to double count it. So it's obviously it's very easy to set these things up together. But actually, if you wanted to kind of do any kind of rebaselining, it might be, you know, if you want to rebaseline your cost and your schedule, in my mind, it's probably appropriate to do that together, particularly if we've got schedule items that are impacting upon our costs. Actually, we want that to be reflected when we rebaseline, but we need to make sure that we're not double counting things, which is a kind of a bit of a kind of like a bit of a nuanced look on things. It's probably take a bit longer to explain that in sufficient detail. So whoever asked that question, if you want to kind of chat about that in a bit more detail, I'd be very happy to talk about that offline. But rather than spending the next 9 minutes talking about that, I'll maybe park that for now and talk about the next question, if you don't mind us here.
No problem. How much percentage and risk, I'm not sure, Okay, it says how much percentage at risk mitigation cost on total cost of project before quotes final project cost. So I think what he's trying to ask is how much percentage, like what would be the correct percentage to calculate as risk mitigation cost?
Yeah. Okay. So look, and again, there's different ways to skin that particular cat. I'm not sure if you've got the same expression in Arabic. We have the expression, there's different ways to skin a cat, which is quite a gruesome image if you think about it. But the idea is that, you know, different organizations do things in different ways. And so one approach is that when we talk about contingency, typically organizations or within particular industries, it might be that the original budget is granted at the P50, for example. It might be the deterministic, or it might be the P50. So that's the kind of the starting point. But the P50 is like flipping a coin in the air and calling heads or tails. And if it's heads, you're going to be less than the P50. If it's tails, it's going to cost more than the P50. So it's not really a particularly confidence-inspiring metric to use when we're funding projects, because the P50, it's really, you know, it could be higher, it could be lower, and there's an equal chance of both occurring. So normally what happens is that organizations will talk about budgeting at the P80 or the P90. And so, for example, here what I've got, this curtain, this contingency curtain, this is showing me the difference between that P50, which is 15.8, and the P80, which is 17.5. The difference is 1.667. And so that means that actually here, if I wanted to talk about how much contingency I want to add in order to be 80% confident that I'm going to meet my budget, rather than 50% confident I'm going to meet my budget, the amount that I would need to add would be 11 days. If we were looking at the schedule side of things, the difference between my P50 and my P80 on the schedule is that I would need to add 35 days of extra contingency to my schedule, which is only equivalent to 6%. So typically the tool will calculate what that percentage looks like, and it will calculate it based on the difference between 2 points. Now, sometimes, of course, organizations will just have you know, in the past, what was very, very common was that people would have 10% contingency on for risk. And so actually, if we look at this cost model here, what have we got? Let's say the deterministic value was 14.968. So actually, I'm gonna do this live for you. So if we go 14.968, rather than trying to do this in my head, I'm going to do it live. So this number here is obviously the same as this deterministic value. And so if I was to add 10% contingency, it's the same as multiplying it by 1.1. And so now this is my, if I added 10% contingency, then I would need to budget for 16.465. So what I'm going to do, you can't see it, I'm pressing the Control C, so I'm copying that number, and I'm now going to put that as my target. And so if I had a budget of 16.465, which is basically adding 10% contingency onto my base estimate, I can see that actually, as a result of that, my target value being 16.46, I've got a 62% probability that I'm going to complete within that budget. So you can kind of tip things on its head. So this is a way that you can test, you know, how much contingent, you know, if we're given this budget, what are the probability that we're actually going to still be able to complete? And so even if you give us an extra 1.6 million, or you know, you're adding 10% contingency, we've still only got a 62% chance that we're going to be able to complete within that budget. There is still a 38% chance we're going to overshoot that, despite the fact we've been given 10%. So you can do all sorts of testing and to see what the value is, but there's no right or wrong way to do things. And you know, some organizations, of course, where you've got a big program, lots of different projects, it might be the case that the project manager gets the P80, but actually it might be that we want to set up an additional curtain here, and actually this might be what we call the management reserve. I'll just write management for time. I'm going to say that what color should this be? Let me see. Let me bring that across here. Let's say I want that to be that color there is fine. And what I want to show on this is that I want this particular curtain to be the difference between my P80 and my P90. And so here what we've got, if I show this on the graph here, let's take off that original contingency. So let's say that the project manager or the risk manager gets the P80. Actually, sometimes what you see, this idea of the management reserve might be where this point here is then the difference between the P80 and the P90. That's how much gets set in a separate account. And so the project manager can't spend it without jumping through all sorts of extra kind of hurdles or, flaming hoops, burning coals, etc. That's set apart from the project, but it's there for those 10% of cases or whatever it is where the original contingency isn't enough. So rather than giving it to the project manager to spend, it's held in a separate account, but it's something which is still available there if the brown stuff hits the fan and it's required. So that was another long-winded answer, which I apologize, but I thought it was worth kind of highlighting that as well. So there's no right or wrong amount, but it's all about testing and then seeing, okay, so based on that level of contingency, what's the chances we're going to meet our objectives? So we've got a couple of minutes left. Are there any other questions?
I mean, yeah, we do have a few questions coming, but I think we're almost
I mean, I'm happy to stay on for a little bit longer. I've got a class in
up with the
in a
time.
little while,
So I would say, yeah. So I mean, thank you so much, Doug. Maybe we can leave your email with them, and then they can speak with you directly.
Absolutely, yeah. Or send me an email or hit me up on LinkedIn. As I said, it's always, as you can see, I'm very excited and passionate about this sort of thing. I'm always really happy to talk about this. As I said, I come out to the Gulf quite a lot, so I'm out in Saudi again at the start of February. So if you want to meet up, even if it's for a coffee or you want me to come and show this in a bit more detail at your offices, I'm very happy to do that. Happy to set up further sessions. If you want to send me an email, if you've got any questions, or send me a LinkedIn message, please do so. I'm always very happy to hear from anybody on the topic.
Thank you so much, Doug. And we're getting raving reviews about your session. So I guess people have really benefited and have really liked your session. Thank you so much for your time. We do look forward to having you again in the near future.
No, thank you very much as well. It's it's been really kind of good to be here, and I thank everyone obviously for coming along to the session, and we've obviously had a really good kind of attendance, and lots of people have stayed right to the bitter end. So thank you all very much for your time and questions and participation. Obviously I haven't been able to speak to you personally, but thank you all for your kind of comments and feedback and so on. I'm just having a quick look at some of the chat stuff. So thank you all very much for your engagement, and thank you also to the PMI for hosting this and for setting this up in the first place. It's much appreciated.
All right. Okay, then.
All right. Good stuff. Well, look, thank you very much. Take care, everybody. Cheers. Bye-bye.
Bye.